It's great to be here on the Hypermill stand on behalf of Interco, who obviously provide a lot of different stainless steels and tool steels. They offer a lot of tool steels like this, but they also offer F55 super duplexes, which unfortunately this is not. This is a hardened tool steel. But what are the challenges with machining such a beautiful part like this in such a hard material?
Okay, so yeah, we're instantly looking at areas where we need perfect blending, super high quality and efficient material removal. Being hard materials, that tool life, you need it to last. You're getting tool breakages halfway through the cut. We can't be dealing with that. So, we've got a number of optimized, cycles and strategies designed for cutting these harder to cut materials.
Let's imagine this was a blank billet right now, and you knew what you had to get out of it. Yeah. But you've got to start with the roughing. Now that's going to be a massive amount of material to take out, which is all going to be really hard. You've got a lot of abrasive wear on the tools. How do you minimise the tool wear, maximise your tool life, while also reducing the cycle times and making a good part in as short a time as possible?
For sure. So there's a whole host of bulk material removal here. So ideally for that, we're looking at the optimised roughing strategy in partnership with the high feed cutting tools, these indexables. Our optimized roughing, it focuses on straight line movement cutting and keeping engagement in the material. So we know there's challenges of when you're exiting and entering the material, get these hot spots and these almost work hardening of the material. The strategy is designed to maintain cut, so you get heat evacuation in the chip, and straight line movement, which helps you to maintain feed rate, so you get the quick.
Yeah, so there's a lot to think about, Josh, when you're machining a part like this. I mean, look at this. You've got loads of little pockets. You've got loads of tiny little deep kind of half bores and whatnot. And it must be an absolute nightmare to try and rough this, because you'll end up with loads of, if you're taking like a deep 25 mil, 30 mil deep cut, and let's say you're doing a trochoidal path, you're leaving loads of big steps that you then got to take out again. So it's all about managing the difference between the roughing and the semi-finishing passes and whatnot.
Yeah, absolutely, Rowan. So when we're starting to move in toward the cavity type areas, you probably move away from the high feed style machining with the indexables and move toward your end mill and adopt the trochoidal style cut. That's helping to again keep the heat evacuation in the chip, high feed, longer tool life, and you're able to get into all the nitty-gritty areas ready for the finishing.
And these are new strategies. I mean, 30 years ago, you would have just really had a shortest path slot milling strategy, which still has its place, definitely when you're using maybe older machines and they can't run so quick. But the new method of doing fast and light cuts, whether those be low depths of cut with a high feed cutter or low widths of cut with a trochoidal, those are fantastic, because you're taking those small light cuts, you're taking them quickly, they're much easier on your machine, much easier on your tool, and you can still rip out the material, a similar kind of metal removal rate.
Yeah, absolutely. It's all about keeping that metal removal rate, and that's where the trochoidal kicks in. It's adapting its feed rate per pass, per line, to maintain a metal removal rate. When you're coming into the tight little corners, you want that engagement increasing. That's going to put extra pressure on your tool. You want to start reducing that feed rate, slow it down a little bit in the corners. And
it's all about the wraparound in the corners and whatnot. But what I love is you could also, so hardened tool steels, really great for trochoidal and high feed, but also the F55 super duplex, the heat resistant super alloys, because you're taking those light cuts, you can still apply those same strategies to all these more difficult to cut materials.
Exactly, yeah. And these are tick box exercises for us. That our cycles are so well developed, you just turn it on and away you go.
It's almost like you don't really care about the material. Obviously, it'll change the feeds and speeds, the kind of cutters, but actually, the cam strategies don't change all that much.
No, absolutely. We've got a couple of roughing cycles. It's all we need for the vast majority of components that you'd ever require in the hard material range.
Okay, so we've talked about roughing. Let's move into the finishing. Now, get a look at these. Now, there's beautiful blends in these corners, Josh. I've got absolutely no idea how you do this, because I was just imagining you've got these flat faces which are flat to axis, which I guess you'd machine straight with an end mill. But as soon as you've got anything with a slight angle on it, you've got to start scanning it out. There's completely different approaches to what, to some layman, which I guess I put myself in that camp. To some layman would look, well, you do that surface the exact same way you do that surface, right? But you can't, because of maybe some weird little angle or some weird little radius on it. How do you achieve these beautiful blends? Look at that beautiful part.
Rowan, yeah, it's an exquisite part, beautiful. Machined in Germany, Fronten, and represents its own challenges. A mixture of ball nosing and the Hypermill open mind innovation, the conical barrel tool. So the conical barrel tool is typically used on all the flat areas, for an efficiency and good surface quality.
Yeah, I can see actually the barrel milling. Sorry, I've just touched it there. The barrel milling. You want to make sure you can show this part off to as many people as you can before it starts going rusty with people like me touching it. But I can see the barrel milling step downs here, and barrel milling is about having. Can you explain how barrel milling works, please, Josh?
Yeah, by having a large contact radius for the surface, you can achieve massive step downs compared to the conventional ball nose. There's other benefits as well, in the geometry of the tool, whereby you increase tool rigidity, and because it's got a small ball on the end, you can build this up from a 3mm ball on the end up to a 12mm shank, 16mm shank, so you can really rigidity built into that tool and setup. So therefore, surface quality and tool life will also increase at the same time.
They're a really fascinating geometry actually, because as you mentioned, they've got that little 3mm ball nose or 4mm ball nose on the end, so you can actually finish a big fat wall with massive step downs. But then if you've got the right ball, if you've got the right radius for the bottom of the pocket, you can then go and whip round the bottom of the pocket radius in like an aerostructure part that has a 3mm radius on the bottom specified.
Yeah, absolutely. And by using the same tool, utilising the same tool in all of the rest material areas, you get perfect blending.
But you don't get perfect blending, obviously, if you just get your materials from any supplier. What you need to make sure is the materials are homogeneous. You need to make sure it's accredited. So you know that the strategies you employ, the cutting tools, and the cutting feeds and speed you employ, they're going to work on that material because it's accredited. It is what you know it's going to be. That's why you need to check out Interco for all your special steels and alloys, for your F55 super duplexes, for all your tool steels, to make sure that when you use fantastic technology like Hypermill, like our cutting tool partners, your cutting tool partners, and you employ those right feeds and speeds, you know that the material is going to be right, so you can make a good part and make it quick and efficiently. Right, let's keep moving on, Josh. Can you explain to me what this part is, please?
Yep, so I'll just swap sides. So this is an engine turbine ring. This was manufactured on a simultaneous mill-turn machine. And, the challenges here, again, with the hard material is we're now having to actually adopt turning into the scenario. And we've got a very special solution for that with our tricoidal turning package from Volume Mill. We do things slightly differently compared to the traditional tricoidal for turning. And we actually do a ramping cut, which increases the cut and decreases the cut as you're going through, changes the cut point on the tool. You can start to increase your speeds and feeds even further compared to the...
It's fascinating. There's 2 points that are fascinating to me about this. It's partly that you've obviously been developing your tricoidal, your Hypermax volume mill machining, which I've used personally. It's all about the lead-in, it's all about the line-by-line feed rate changes in the corners, all that good stuff. But you can apply that exact same idea, which is kind of in a 3-axis, you kind of go like that, to a 2-axis lathe. So it's the exact same toolpath, but you just kind of flip it on its head. It goes down in the X and the diameter and the Z.
It's got all the benefits as well, in comparison to the milling. We're controlling the feed rate, adapting the feed rate into the corners. Yeah. It's a superb solution.
It's a shame you don't show, this is a beautifully finished part, but it's a shame you don't actually show the results of the roughing operations. All you see here is the finishing. So those roughing operations might only take, 10, 15, maybe 20, 30 minutes of the total part time. But what we're seeing here is the whole, this maybe 12 hours worth of finishing that's gone into it. It'd be nice to see actually a stage by stage breakdown. Maybe you could sort that out for next match.
Video going for you guys, no problem.
Yeah, definitely. So this is again a beautiful part. This is a tool steel again, I think. So they've got the materials in a German standard that I'm afraid I don't know my materials that well.
It's a tool steel.
It's a hard tool steel, and again the tricoidal mill. It's funny how, but these engine turbine rings or engine casings, these are parts that have been made for 30, 40 years. So it's the same kind of form, it's the same kind of part, it's almost probably the same kind of material. Maybe they've improved in homogeneity or some parameter over the years, but you're using completely different modern ways of making them, completely different operations, which is great how the parts don't change, but the processes and the ways you make them do, and obviously the cycle times will be heavily reduced.
Hey, look, with the material advancements, the cycle and the machines and the tooling, everything that goes into these has to move forward for better efficiency and better quality. And it's cycles for us like the shape offset roughing, which allows us to use 5-axis tricoidal machining, to machine these dome faces. That actually, you mentioned about the roughing. Yeah, it's the perfect solution. You're getting near net shape on almost freeform surfaces from a roughing scenario,
which you never normally get. You normally get really awkward, weird steps going down, but because your tool can rough I mean, I think I've actually used that to machine the base of like a blisk, or your straight blisk. You use the bottom because you're following that bottom curvature, and it's just taken out all those semi-finishing operations just to get from the roughing horrible steps that are left to the lovely last little 1 mil off the surface ball nose finishing. And you guys are, every time I come to one of your stands or see one of your videos, you've always got a beautiful part to show off. You had the crown, you had the panther, you got the stiletto. Yeah. Everyone loved the helmet. Obviously, who could forget the helmet? But I've got to say, this is probably my favourite. The hardened tool steels. I'd love to see you make nice parts in aluminium, but hardened tool steels, you can't get much better than that. Next time, you're going to try and make something in maybe F55 super duplex from Interco.
Give it to us. We'll do it.
Okay, maybe Les can sort that out. Maybe you can send a little bit of material over to Hypermill. They can show it off. But that's it. I've learned so much today about tool steels, about cam strategies. Thank you very much, Josh.
Thank you, Rowan.